Okay, so here's our first video for Chapter 2. The focus of Chapter 2 is organizing data, so here we're going to be talking more about descriptive statistics. Specifically, the focus for this video will be frequency tables, which we talked about in class today. This video is going to go a bit quickly because we actually went over all of this material in class, hopefully, and my main objective in having you watch this again is to give you an opportunity to hear it again, to review your notes, and try to solidify your understanding. So starting with the definition of frequency table, in case you missed this in class, a frequency table splits the data into classes or intervals and shows how many data values are in each class. The classes or intervals are constructed so that each data value can fall into only exactly one class. Now, I gave you a handout in class today which included this view here of how to make a frequency table, the steps. If you need to copy that into your notebook, you have a view here. You can certainly pause this and take notes as you need to. Now, the example we were discussing in class was related to a situation where we have a task force encouraging carpooling who did a study of one-way commuting distances of workers in the downtown Dallas area. So, based on a random sample of 60 workers in the Dallas area, the following commuting distances were obtained. You see in the footnote here that these are in miles, so commuting distances in miles, and the specific commuting distances captured you see in the table. So we have a total of 60 instances captured. Okay, so just as we did in class, I'm going to show you the solution first. So this is the frequency table where we're capturing the information on the 60 commuters who were randomly selected. And you'll see to the far left, we've got our classes. So these define where the data values go. We've got our class boundaries, which we need to be able to set up the histogram. We do our tallying here. So this is where we count how many instances fall within the class from 1 to 8 miles versus the class from 9 to 16 miles versus the class from 17 to 24 miles, and so on. We count up those frequencies over here to give actual numbers so we know how high to make the bar of our histogram. And then lastly, we have the class midpoints, which we can kind of use as averages for the classes just to have an idea about what the class represents. So the class from 1 to 8 miles distance, on average, the instances, the 14 people that we talk about in that class, their average commute we might think of as being 4.5 miles. So that's what we use the class midpoint for. Okay, and I also want to show you the histogram for this data set. This is what we're ultimately able to build using the frequency table. So we see on the bottom, we see our class boundaries, so the 0.5, 8.5, 16.5, and so on. These are what we use to kind of set off our bars. There were no data values that were 0.5 or 8.5 or 16.5, so they're nice breaking points. But obviously that means between 0.5 and 8.5, we have in this first bar the data that represented 1 to 8 miles. Okay? And from our frequency table, we know that there were 14 instances of commuters who had commutes between 1 and 8 miles. And so on. So we saw an example in class today, a video showing how a frequency table can be converted to a histogram. This is a more sophisticated approach using the class boundaries that you see at the bottom here, and then our frequencies along the left-hand side vertically. Okay, so we'll run through the steps, and you can follow along with the handout I gave in class to track how to create the frequency table. The first thing we need to do is decide how many classes we want, okay? And usually the minimum is 5 and the maximum would be 15. So no fewer than 5 and no more than 15 is what we want to do here. Okay, and usually we'll get some guidance when we're doing these frequency tables as to how many we should plan to use. In the case of the commuting example, we're using 6 classes. Once we know how many classes, then we need to find the class width. The class width allows us to determine what data values will fall into which classes, and we use this formula here. We find our largest data value in the set, we subtract the smallest data value in the set, and then we divide that difference by how many classes we want. If needed, we then round to the next highest whole number. Okay, so in our specific example, our max commuting distance was 47. The min in our data set was 1. We find the difference between those two, which is 46. Divide by our number of classes. We said we wanted to do 6 classes for this problem. 46 divided by 6 is approximately 7.7, but we increase that to the next highest whole number, or 8. So our class width will be 8 for this problem. Okay, so when we have our number of classes and our class width, then we need to use that information to determine the data range for each class. We need to be able to say specifically what data items go into which classes. Now, the lower class limit is going to be the lowest data value we can fit in a class. The upper class limit will be the highest data value we can fit in a class. And the class width is going to be the difference between the lower class limit of one class and the lower class limit of the next class. And we'll see what that looks like in a moment. So if we would look at our example for commuting distances, the smallest commuting distance in our sample is 1 mile. So starting with 1 mile, we're going to set the lower class limit of the first class. That will be equal to 1. And since our class width is 8, we add 8 to 1 in order to find the lower class limit for the second class, which is 9. And then we follow the pattern to establish all the lower class limits, and we'll see what that looks like next. So here we go. For the lower class limit for the first class, we said that would be equal to 1. Our class width is 8, so we add 8 to 1, and the lower class limit for the next class is going to be 9. We add 8 to 9 to get the lower class limit for the following class, which will be 17. We add 8 to 17 to get the lower class limit for the next class, which will take us to 25. Okay? And we can do the same thing with the upper class limits. If we add 8 to 8, we get the upper class limit for the second class is 16. If we add 8 to 16, we get the upper class limit for the next class is 24. If we add 8 to 24, we get the upper class limit for the next class is 32, and so on. So here you see the lower class limits and upper class limits for all 6 classes. And again, the difference from one lower limit to the next is going to be 8. We're adding 8. We add 8 here. We add 8 here. We add 8 here, and so on. And the same thing here. From the upper class limit, from one upper class limit to the next, we're adding 8. From 16 to 24, we've added 8. From 24 to 32, we add 8, and so on. Okay, so we're using that class size of 8 to help us establish the lower and upper class limits for each of our classes. Once we know our classes and the data ranges for each class, now we can go ahead and tally up our data. If you're not sure about how to tally, please go ahead and read the section at the bottom here, and you can take notes on it as needed. But otherwise, most of us are probably pretty familiar with the method of tallying where we tally in groups of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. So if you're looking at the data set on the handout I gave you, you should find that there are 14 commuting distances between 1 mile and 8 miles. So as I identify each of those commuting distances, I do my tallying, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, for a total frequency of 14. Okay. Once I do that for each of my classes, I should have a tally and a frequency that looks like what I've circled here. So 14 commuting distances between 1 and 8 miles, 21 commuting distances between 9 and 16 miles, 11 commuting distances between 17 and 24 miles, and so on. The next thing I want to calculate is the midpoint for each of my classes. This is kind of a representative value for the entire class. Okay? The way I find this is by adding the lower class limit to the upper class limit and then dividing by 2. It's really an average of my lower class limit and upper class limit. So if I look at my lower and upper class limits at the left here, if I look at my first class, my lower class limit is 1, my upper class limit is 8. I divide the sum of those by 2 and I get 4.5, which is what I input over here in the class midpoint column. The next one would be lower class limit of 9, upper class limit of 16, divide by 2. I should have 25 divided by 2 or 12.5, which I put over here. Oops, pen is not working so great, but 12.5 for my second class. That would be my class midpoint, or kind of the average commuting distance for that class. Once I do that for all my classes, I should have the class midpoints that you see here. Again, I'm just adding the lower class limit to the upper class limit and dividing that sum by 2. So if I look at this last one here, if I do lower class limit of 41, upper class limit of 48, divide that sum by 2, I get 44.5. The last thing I need to find to complete my frequency table is my class boundaries. Okay. These help me determine where to draw the lines for my histogram. Class boundaries should not be the same as any of my data values. They should be outside of my data values. So when I'm going to find my class boundaries, to find the upper class boundaries, I'm going to add 0.5 to the upper class limit. Okay. And to find the lower class boundaries, I'm going to subtract 0.5 from the lower class limit. So let's see what that looks like. Okay, so if I look at my first class, which ranges from 1 to 8, my lower class limit is 1. Okay, so lower class limit equals 1. When I subtract 0.5 from 1, I get 0.5. So that's my lower class boundary. My upper class limit, let's say UCL, my upper class limit is 8. And when I add 0.5 to 8, I get 8.5. So notice I have no data items, no commuting distances that are 0.5 or 8.5. These are exactly in between my lower class boundaries and my upper class boundaries. So for example, if I look at 8 here and 9 here, right? I have commuting distances that are 8 miles. I might have commuting distances that are 9 miles, but I don't have any commuting distances that are in between those 2 points at 8.5. So 8.5 is one of my class boundaries. When I calculate all of my class boundaries, this is what I see here. Notice, if I look at the lower class limit of 1, the class boundary I subtract 0.5 from, so I get 0.5. Upper class limit of 8, I add 0.5 to 8 to get 8.5. Lower class limit of 9, I subtract 0.5 to get 8.5. Upper class limit of 16, I add 0.5 to get 16.5. Lower class limit of 17, I subtract 0.5 to get 16.5. Upper class limit of 24, I add 0.5 to get 24.5. And you start to notice that the upper class boundary of one class is the same as the lower class boundary of the next class. And that's intentional. As you see, when we draw the histogram, we use these to divide up the classes. Okay, so you will see that pattern. Okay, so your homework for tonight was to watch this video. So if you've done that and taken your notes, give yourself a big pat on the back. Be on the lookout for a remind from me about what we are doing tomorrow. Have a great night.